Billions of galaxies are scattered throughout our universe. But how did these massive collections of stars first form? Astronomers are working to understand the critical but long overlooked role that gases play in a galaxy's life and death.
Galaxies are more gas than they are stars, by mass and most certainly by volume.
Scientists can't go back in time to watch galaxies form, but they can create simulations based on observations of the universe around them. These simulations help astronomers like Jessica Werk to ask specific questions about the life cycle of a galaxy.
This particular magenta spiral that you see here is what we know and think of as a galaxy. In particular, this is similar to our own Milky Way galaxy and how its gas is distributed in a disk.
This simulation shows how gases, in flux over billions of years, might have breathed life into a galaxy much like our own. As the simulation progresses, redshift, an indicator of space-time represented by Z in the top left corner, counts down to present day from a moment in the universe's distant past.
The simulation begins approximately 13.6 billion years ago. What you see is a region of space that will eventually contain a galaxy like the Milky Way. It's very simple, where it's very cool gas of primarily just hydrogen. And as time starts progressing, you start seeing this material collapse into this filamentary web-like structure, which is known as the intergalactic medium. This is gas that makes up the space between galaxies.
The intergalactic medium hugs the outer bounds of the circumgalactic medium, a denser region of atoms like carbon, hydrogen, and oxygen that surround the central star-forming disk of a galaxy.
And so you can imagine the circumgalactic medium is more like a dense knot in the intergalactic medium, surrounding an even denser structure in the center, which we call a galaxy. And the intergalactic medium and the circumgalactic medium are constantly exchanging their atoms with each other. And over time, this material is becoming warmer, and that's where the color changes to a greener color, and even hotter gas, approximately 1,000,000 degrees, is shown in red, and you can start to see that from the very first explosions that are happening. Primarily in this simulation, the explosions are generated by stars ending their lives violently in supernovae. Just about in the middle of the history of the universe is a time that we call cosmic noon, the heyday of star formation. Galaxies and the stars in galaxies behave very differently. They're much more violent. They're forming stars much more rapidly. And after this period, as we move toward what's known as cosmic dusk, star formation is dying out, because what's happening over time is that this circumgalactic medium is heating up. And when gas heats up enough, it's not going to be able to cool and form new stars in the disk of the galaxy. And so by the very end of the simulation, things look a lot redder, they look a lot hotter. And this is kind of the beginning of the end phase evolution of galaxies, where we think that ultimately star formation will die out in galaxies and is presently dying out. Over time, the galaxy grows its mass, and by doing so, it increases its gravitational attraction of other smaller galaxies, these small spiral lumps that are ultimately coming into the circumgalactic medium and may in fact be completely cannibalized by the now much larger galaxy at the center. So eventually we can draw our focus to this magenta spiral at the center of this simulation, which is the gas in the disk of the galaxy. The formation of this beautiful spiral structure was in fact a series of incredibly violent events, from explosions to collisions, and then you ultimately end up with this beautiful spinning magenta cool gas disk of a galaxy.